Everyone, welcome back to another iBuddy video, and today we're gonna be talking about this important topic that you're gonna get back to like through the rest of your high school career, and like it's just essential for like knowing itself overall, which is law of exponents. So let's begin. So by the end of this lesson, so this is the learning goal. By the end of this lesson, I meant to say you will be able to demonstrate how to simplify powers by multiplication and laws of powers or power itself. So what are powers? What are exponents? What are powers? As you might be wondering, if you don't know. So basically, powers is basically telling us like this is our base number, right? Let's say we have five, and then we have to the power of two. So five squared rooted. No, five squared. Sorry. That is basically five times five, which equals 25, right? Don't worry about this part, like equals to 25. That's kind of your calculator's job, but so we're just basically trying to learn what 5 to the power of 2 or like to power of a number means. Also, don't mind my handwriting or like the numbers I'm gonna be putting here because I don't have my pen today, cause like pen because I lost it kind of. So not a worry, but kind of my worry because my handwriting is gonna be pretty bad. And so let's try this first question itself, where we have to state the base and exponent for each. So as we just talked about, base is the number at the bottom. Base is like, let's say, a number being squared, cubed. Cube basically means a 5 to the power of 3. So this is our base, and cube means to the power of 3, right? That's our exponent. 3 is our exponent. So here we have 5 to the power of 4, and so base is going to be 5. Why? Because it's at the bottom and it's being multiplied to itself 5 times essentially. Because it's 5 times 5 times 5 times 5. And this would give us something around 5 times 5 is 25, 125, and 625, right? As I said, don't worry about this part. You'll get back to this. It's just mental math. It's good for you, but if not, you have a calculator to help you with it. So our exponent is 4. Now they're saying that we have negative 5 as our base, right? And to the power of 4 again, right? So here, what happens? So what's the difference between this negative 5 and this negative 5? I'll give you a second to think about it, and then we'll get back to it. I I give you a second to think about it. So when they're saying negative 5 in a bracket, that means negative 5 times negative 5 times negative 5 times negative 5, right? And that basically is the same thing as saying 5 times 5 times 5 times 5 because it gives you 625. But when they're saying negative 5 here, only a singular and none in bracket, let's do this somewhere here, right? That basically means negative 5 times regular 5, positive 5, times 5 times 5. And that will give you negative 625. Like, we get the difference because when it's in bracket, they're essentially saying that's the same number being repeated over and over again, which we can see here negative 5 times negative 5 times negative 5 times negative 5. But when they're saying that's negative 5, not in a bracket, to the power of 4, that basically is saying that there's only one negative 5 and all the other 5s, like all the other 5s are positive. Okay, that was kind of off topic, but it was important to talk about because when I was you, I had a lot of trouble understanding this, and I thought explaining would be helpful. So here, our base is 2x, and our exponent is 1. And now we have base of 7 and exponent of negative 2. And when we're talking about a negative exponent, it just means 1 to the power of 7. Oh, I mean 1 over 7 over 2, which equals 1 over 49. So you just basically flip it and make it a fraction, right? Now we have negative 5 to the power of 4. So our base is negative 5 and exponent is 4. And now we have 3x and exponent is 4. So it's just 3x times 3x times 3x times 3x. Sorry. So now let's try this question. This is kind of like you guys do yourself, like the question I'm gonna make a square around, and every other question we're gonna do like together, because it's the same kind of like same thing that we're gonna be doing. So this is gonna give us so we have two h's, h times h, right? and now we have another times h times, there's four h's. It's pretty redundant, but like once you get the topic itself, like you can skip, like you can put my video in 2x and just like carry on with life, like do homework. So this gives us h squared, and this gives us h to the power of 4, which is h to the power of 6, because 2 plus 4 is 6. 6, 7. Sorry, off topic. I'm sorry. Now we have 8p's. Oh, I have to draw all of them. P times P times P times P times P times P times P and times another P. That's 8. And all my days in P to the power of 5. I'm sorry, guys. And that basically gives us 5 times 8. 5 plus 8 is 5 times 5 plus 5 is 10. And 3, so 13. Exactly. Right? And now, because I am now we're giving homework, so we're gonna do this ourselves as well, like with me. So we have the same base. We have an exponent which is a, an exponent which is b. So what do we do with them? We're essentially just adding them. So it's x a plus b, and that's kind of our single power two kind of. So okay, the same thing. See, I told you it's pretty redundant. This switch fixed it, but it's okay. I was being lazy. Now we have m to the now okay, we're done with multiplication. So the basic rule with multiplication is when two numbers are being multiplied, it just means that they're being added. The exponents, if there's the same base and they have different exponents on top, it just means they're being added itself. Okay, so if it's x is the base as we saw here, and we have a times x to the power of a times x to the power of b, it just means x to the power of a plus b. Okay, all right. Now we have m to the power of 6 divided by m to the power of 2. So if multiplication was adding the exponents, then division is going to be subtracting the exponents. Good job. So this basically is trying to show us that there's un the trois quatre cinq and six m's, right, over two n's, m times m. And as you know, when we're dividing, we can cancel out 1, 2. So we're going to be left with what? M to the power of 4. Now they're saying that there's 4 a times a times a times a over a times a times a. These two cancel out, these two cancel out. You're only left with a to the power of 1, which is equals to a. Good job. Now we have x to the power of a divided by x to the power of b. And that basically just means x to the power of a minus b, because when we're dividing exponents, we're essentially, when we're dividing two different numbers with different, like same numbers with different exponents, so same base but different exponents, we essentially just subtract the exponents. So here it's going to be x a minus b. Okay, now let's try these practice questions. I'm going to do a and c, and you guys are going to do b and d yourself. Okay? Now, okay, so we have 7 to the power of 4 times 7 to the power of 5. So what did we learn about when we multiply them? So 7 to the power of 4 plus 5, because we're multiplying with the same base, that gives us 7 to the power of 9. And if they told us to like simplify into one answer, then we would have plugged this in our calculator, 7 to the power of 9, or 7 times 7 times 7 times 7, 9 times. And that would have given us like a singular number itself. Okay? And that's our answer. You guys got this. I taught you what happens if it's -9 inside a bracket and like outside, like if there's no brackets around the negative number right here. So if you have to go back to do this question, then please do, because this is very important. And now we're gonna move on to C, because these two are your homework. Okay. So we have x to the power of 4, y to the power of 3, x to the power of 3. So we know bedmass, right? Brackets, exponents, multiplication, division, essentially, then multiplication, and then bedmass, and then addition and subtraction. and where division and multiplication are interreversible, and then also addition and subtraction too. So here we have x to the power 4, y to the power 3 being multiplied with x to the power 3, y to the power 5. So what happens here? So because this is like brackets, and I just think of this as something on itself first. So we're going to do x to the power 4 plus 3, then y to the power of 3 plus 5, and that's going to give us 3 plus 5. Wait, let me get my eraser because I can't see the bottom. And that's going to get us x to the power of um, x to the power of 7, y to the power of 8 over x to the power of 5 and y to the power of 5. And our answer, because it's division now, right? We're done with multiplying them. So we have x to the power of 7 over x to the power of 5. That gives us x to the power of 7 minus 5. And y to the power of, what was y again? 8, y to the power of 8 minus 5, right? So 7 minus 5 is 2. So our answer is going to be x to the power of 2, y to the power of 8 minus 5, which equals 3, right? So we have two x's, so x times x, and we have three y's, y, and y, right? Okay, now let's do a power of a product. So when we have something like x cubed, right? So we have something like x cubed, and then there's a bracket and it's being squared. So this essentially just means that these two numbers are getting multiplied. So that basically means x to the power of 3 times 2, right? And that just means x to the power of 6, okay? That's a 6. Don't worry about my handwriting as I mentioned before as well, because writing with a mouse is pretty difficult, more difficult than I thought it would be. Okay, so now we have here y to the power of 3 inside a bracket. So that basically means we have three y's, y times y, and it's being repeated four times. So we have y times y to the power of 3, like y times y being repeated four times. Do we get this? Because let's say we have y to the power of 3, that means there are three y's, right? Y times y times y, right? And then we're saying that y times y is being repeated four times. That means y times y times y times y times y times y, like four times. Is essentially just saying this. Like there's like instead of saying y to the power of 3, there's y times y instead of bracket, and that's being to the power of 4, like being multiplied to itself four times. Okay? So we have y times 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 y, and another bracket. Okay? This is like if you don't get the concept and you wanna be making sure that you know like your answer is right. But if you want to be quick with it, then instead of like doing it and expanding it, right, we can easily just do what I just told you guys, which is to multiply these two, 3 times 4, because look, 1, 2, 3, 4, 5, 6, 7, 8, 9, 6, 7, 10, 11, and 12, right? Right? 12. 12. 12. Sorry. Another one. I was just going with the Y's. Right? So 12. And what's 3 times 4? So 12 itself. So it's just y to the power of 12. That's our answer. So there's no need to do the steps, so I'm going to be skipping it. But for this question, if you guys need extra help or like need to do the step to make sure that your answer is right, go ahead. It's like better to hurt your hand to get a better mark on the exam because you're going to be happy, right? And now we have w to the power of 5, so w times w times w times w times w being multiplied to itself twice, so one bracket and two brackets. So essentially, our like single power is going to be w to the power of 10, because 5 times 2 is 10. Good job. And as I just mentioned before, x to the power of a inside a bracket, and then b outside is just going to be ab. AB with a dot in the middle, multiplying sign across, whatever you prefer, right? Now, this example we're going to do by ourselves. This is homework, and I just mentioned that before as well. If you need help with negative numbers, all that, then please go up here and understand what I mean to say, because this is important. Okay, so we have 2, 2, and 4. So just 2 to the power of 8. Y times 4 is 8, so we have 2 to the power of 8 because if we do, okay, I'll show you to you in expanded form. So we have 2 times 2 here, then power of 4 is gone, right? So because we open it up. So we have another 2 times 2, we have another 2 times 2, and we have another 2 times 2, 2 times 2, sorry. This is our first, this is our second, this is our third, this is our fourth. So 1, 2, 3, 4, 5, 6, 7, and 8. 8 to the power of 8. That's our answer. Awesome sauce. Alright, now just the last part. I know this video has been pretty long and I'm gonna make another part after this, but it's helpful to have a tutor that's teaching you guys and helping you with IB stuff because IB, like in grade 9, seems pretty easy, but it does get intense. Now we have A over B to the power of 7, right? It's a same thing, same thing. Expanded form, do you guys want me to like, okay, I'll do it for this question. I'm not gonna do it because it's pretty. Okay, so we have A over B multiplied to itself 7 times. A over A over B 7 times. Okay, this was A over B, A over B on the 12th has the same A over B, and that basically just comes out to A over 7 to B over 7. Awesome, right? And because the bases are not the same, we really can't just subtract them, right? Because remember, for division of dividing the powers, we need to have the same base. Like here was M and M, here was X and X, here was A and A, like, right? And because the base is not same, this is our single power answer. Now for this question, it's the same concept, but here what you're gonna have to do is 2xy, xy, right? 2xy, and another 2xy. Sorry, I'm actually so sorry. Like my handwriting doesn't really suck. I agree. Xy, right? And that is gonna come out to 2 to the power of 3, x to the power of 3, y to the power of 3, and that is going to give you 2 to the power of 3 is 2 times 2 times 2, right? 2 times 2 times 2, which gives us 4 and 8. So 8x cubed, y cubed. If you don't know what I mean by cubed, so a number to the power of 2 is called squared, a number squared, and a number to the power of 3 is called cubed, and so on. Okay? Now, I'm only going to do two of these because I've given us enough examples up here to be doing these ourselves now because I'm not going to be there to help you with your test exam, whatever comes. And I think it's going to be really helpful for you guys to do this as well because practice makes improvement, not perfect. Remember that. Same question as we did up here 6xy to the power of 2, right? 6xy, 6xy. That just gives us 6 to the power of 2, x to the power of 2, y to the power of 2. That gives us 36 x squared, y squared. Okay? Awesome. This, I'm going to say you do yourself because it's the same concept as this question, essentially. And I think you guys are enough. Like, I've taught you enough in this lesson itself that you're going to be able to do it. Now, let's do this one ourselves. This is the same, going to be the same concept, and then we're gonna do this, and these two are you guys. Okay? So we're gonna basically do A, C, and E, and B, D, F, and G are kind of like I'm gonna circle them because these ones are what you guys are gonna be doing yourself. And if you need help, let me know on the Google Classroom, and I'll just tell you guys the answer. Okay? So we have this, and now we're gonna do two A squared B 4 multiplied to itself 3 times 2A B4 2A squared B4. So 2 times 2 times 2, that gives us 8. And then we have A to the power of 2, A to the power of 2, A to the power of 2, which gives us A to the power of 6 because that's we know is the same base getting multiplied. That means the exponents are going to be added. A to the power of 6, and then B to the power of 4 being repeated 3 times. So 4 times 4 plus 4 plus So 8 a to the power of 6 b to the power of 12. Awesome. And now here we have n to the power of 4, n to the power. Okay, so first, what we're going to have to do to open the brackets, because n massive brackets, right? And then we move on. So it's going to be n 4 times 2, because as we learned the exponent rule up, where was it? It was up here, right? When there's an exponent to start a base, and then there's um, like power for power itself. We have to multiply that many numbers, like what we can see over here. Okay, right? So n to the power. What was that right? Hey, I can't even understand what I wrote, so I really don't know how you guys are gonna understand. I'm sorry. I apologize, guys. So here we have. Oh, okay, what happened? Why do I have a highlighter? Loki looks better. Okay, we have n to the power of times. Oh my days, this is not gonna work. Sorry, guys. I was trying to test out something that might make it easier for you guys to see. I guess let's use black actually. If I haven't, I've been using black. Okay, we have n 4 times 2, and then here it's going to be n 2 times 3. Oh my days. 2 times 3. That's going to give us n to the power of 8, right? Being multiplied to n to the power of 6. Because 3 times 2 is 6. So these in brackets easier. And now we have the same base into exponent. So what are we going to do with this? I'm sorry, I'm going to go in like this area. Um, and now this is going to come out to be n to the power of 8. So it's going to be n 8 plus 6, which gives us n to the power of 14, because 8 plus 6 is 14. And why do we do this if you're asking yourself? Because they have the same base and the exponents were different and they were getting multiplied. So we just added them. Awesome stuff. And with that, we come to the end of the part one of exponent laws, means the lesson itself. It's a pretty straightforward lesson, so you can put it on 2x and just move on. And if like you guys have any other questions, please let me know in the comment section of Google Classroom. Like ask, right? Asking helps. And thank you once again. Just remember, I'm the best teacher on iBuddy. Thank you guys, and I'll see you shortly in the second part of exponent laws. And just remember, this is very important. Very important. Very important. Okay, guys. See ya. Au revoir.